So today I'm going to be talking about how AMD hardware is pretty phenomenal and how AMD hardware combined with innovative software can get the best out of the silicon and also give you a lot of optionality and choice. So let's dive in. If you aren't familiar with image diffusion models, like what the heck is that? Why are they hard? AI seems like it's going so fast. What's happening in this space? Well, image diffusion models are used all the time. You've used all these things that generate images on ChatGPT and other places. But when you look at these models, they're a little bit different than what you'd see with a text model. Like, sure, they have LLMs in them. They have a lot of different capabilities. But actually, they're ensembles. They're multiple different models put together. And so if you look at a model like Flux 2, this is a very popular model from Black Forest Labs. It's very widely used. It's actually 3 different components. It's got an encoder on the front, it's got a part that goes and refines the image, and then it's got a decoder on the end. And these models are individually very complicated. This is something that it turns out that you have entire specialists in each one of these areas to design, optimize, map it onto hardware, and so this is actually quite a lot of complexity. The other bigger problem, though, is that technologies like PyTorch, though we love them, they were never really designed for this. And so typically what you get is you get a model for each of these parts. Maybe you have a different Unix process with a different instance of PyTorch, but you have one set of GPUs. You have one set of resources. And so when you end up wanting to deploy this, you get a ton of complexity because this is just not, it's transformers. And so there's definitely Gen AI standard components in this, but it's not just the text-based LLM that everybody's very lasered in onto. Now, the other big problem, which is kind of a macro problem if you care so much about AMD, like many of us do, is that a lot of the innovation and a lot of the research happens on NVIDIA. And I think a lot of folks want choice, but a lot of the software ends up being accidentally built for NVIDIA because the people building this, if they have NVIDIA chips sitting in front of them, they're not looking at building scalable software. They're looking at solving one problem. And so they're not going to think about portability. They're using CUDA. They're using all these technologies, which they're really productive for getting one thing done. And they don't really care about the next day. They just want to ship their model. So what is Modular doing about it? Well, we've been working on building AI software for 4.5 years. We've taken a big swing. We've taken a very different approach that's very next generation, but it leads to some really interesting things. And so I'll introduce what we're doing, and then we'll talk about what it means for image diffusion models. So the Modular stack, to make a very long series of tech talks very short, it really has 3 components. It has Mojo, which is a programming language. We'll talk about it a little bit more. Please check out our booth, get a sticker, super awesome. Get your Mojo on. Mojo is really great for writing high-performance AI kernels that are portable. We've got Max, which is an AI framework. And so think about this as a VLLM or a PyTorch combination, or all these technologies move forward to be modern Gen AI inference native instead of built for traditional AI and training. And so this is what Max is. We'll talk about this more. And then Modular has a cloud. And the cloud makes it super easy to build and deploy. You can serve on your own compute. You can use our hosted inference if you'd like. But all of this is very open. It's designed for hackability, and it's designed for customization. And so I'll dive a little bit into each of these just to give you a sense of what these things are and why you might care. Well, so when you start with, at the bottom of the stack, you have the GPU. And a lot of people think about, how do I get a kernel to run fast? How do I get matrix multiplications? How do I get flash attention 4? How do I get this innovative new thing that DeepSeek came up with last night, right? And so the problem with this is a lot of the technologies in the space are either C++ things like CUDA, or they are these Python DSLs. And there's dozens of these Python DSLs, but you're basically choosing between welded to one vendor's hardware or not getting the full performance of the hardware. Well, Mojo is a completely new programming language. It looks like Python, but don't let that deceive you. It's actually a completely new programming language, a full new compiler. It builds on the best part of Python, which is its ecosystem and also its syntax. But it's a complete rethink of programming languages, how compilers work, and it's built for this modern multi-GPU, multi-AI accelerator world that we all live in. And so Mojo is super awesome. If you'd like, you can check it out. It's open. And we're actually encroaching on 1.0 later this year, which is super cool. I'm not going to deep dive into Mojo. I would love to, but that's not the right place. All I'll say is that it is actually a modern language. And so if you're familiar with languages like Swift or Rust or things like this, Mojo is taking the next step. We're not doing a cute little science project on the side. This is a big investment, and sort of bringing the best of programming languages into the space. Now, if you go to the next level up, we have Max, and I told you it's a PyTorch VLLM type thing. Well, it's really about learning from what's great about PyTorch, what's great about VLM, SGLang, TRT-LLM, and like all the different technologies in the space, and make it so we can scale. And so what that amounts to is a Python or a PyTorch style API that is super easy to learn, super easy for the LLMs to generate, by the way, also. And it's great for building models. And so we built a whole bunch of different models. They're all open source. You can check it out. But what we solved is we solved a lot of the problems that make it difficult to productionize and deploy PyTorch code. And so, for example, with PyTorch, you have torch.compile and export and things like this. It can take a long time to compile your model and export it. Also, if you're running in production, often your latency can spike when your shapes change and things like this. And so there's a lot of things that, it's possible to do things in PyTorch, but it leads to a lot of like really very significant production challenges. And also when you're talking about portability, we care a lot about a lot of silicon out there, including NVIDIA and AMD. And so Max is designed to be GPU agnostic by design, not like built for NVIDIA and then AMD is helping catch up. And so if you dive into this, again, I'm not going to give you the full tech talk, but this is a very rich ecosystem. And so you've got the ability to build the models. Again, because we're in a modern world, people care about serving the models, not just training them. There's a whole bunch of different things for performance optimization. And Max was designed not only to be native for Gen AI, but it's also native for Mojo. And so Mojo and Max were co-designed because today you want really fancy compilers to do automatic fusion. You want all these new technologies that give you portability, performance, and productivity combined together into one system. Now, I'm not going to go into all the things as usual. There's a ton of cool stuff. We could talk about offline graph compilers and eager mode and like all the amazing things and what you can do with custom kernels. But I want to actually jump back and also talk about the scalability. One of the key things that we as Modular see is that a lot of people are on NVIDIA. NVIDIA has good flops. They have a lot of systems out there, and they have an incredible install base, and they're on NVIDIA. But they really want choice. Right? And I think a lot of us want choice, and we see the advantages of AMD silicon. I'll talk about some of them later. And so the key thing about our stack is we have this fully vertically built stack with our own kernels, our own models, our own serving components, all this stuff. And that whole stack was built for portability so that you have choice as a customer, whether you're running on NVIDIA or you're running on AMD. And what a lot of people want is they want to start on NVIDIA and expand. And the cool thing about the stack is that, yeah, there's lots of cool technology and performance wins and TCO and like stuff like that. But what it does is it gives you flexibility. It gives you the ability to scale. You can scale onto AMD, even if you have a 3-year contract for NVIDIA, and you don't have to manage 2 software stacks. And that simplification, that allowing you to focus on building your application-specific awesome optimizations and things like this is what I think propels the world forward, and we've seen a lot of people being very excited about this. But let's, I forgot this slide. Yeah, so what does it mean? So if you're building models, if you're customizing things, you have full power, and so you can intercept this stack at any layer, no matter what you'd like to do. So let's actually talk about applying it. Right? So come back to image models. We talked about why they're a little bit hard, a little bit weird. Let's talk about what it means on AMD and what it means for these kinds of newfangled things that people want, like image generation. Well, one of the cool things you can do today is if you go to the modular.com website, you can see there's a little widget where you can generate images. You'll see that you can generate images faster than you can type. Now, I don't know about you, but normally the latency of generating an image is like 7 to 10 seconds. Of course, you're generating a huge one, it can take much longer. But once you get it sub-second, this is not sped up, this is real time. Once you get it sub-second, it dramatically changes the experience. But how can you achieve that? The only way to do that is if you take all of these different layers and all the different Python weird things, all the different PyTorch weird things, and break through and build that unified and integrated stack that allows you to take those 3 complicated hybrid models and actually execute them effectively. But this is technology. What we care about is product, right? And the fact that you can do that transforms what people can build for their products. And so if you'd like, you can check out the implementation of this. Our stack is open, and so you can go to the Modular website and the Modular GitHub, and you can see, okay, it looks basically like PyTorch. Right? In fact, you can vibe code a lot of PyTorch over. You can also vibe code a lot of CUDA or Triton or RockM or whatever into Mojo. That's actually a very important part. Our open source strategy is a key part of our corporate strategy. We believe that AI should be open, But we also believe that AI agents and coding tools do best with data. And so if you go to our GitHub repo, we have, I think, the world's biggest open kernel collection, written in a consistent style, multi-hardware, NVIDIA, AMD, and Apple, by the way, for developers. And so that allows the AI agents and the LLMs to do amazing things, pulling things into the ecosystem. And because we're running on NVIDIA, you can often take that code from some NVIDIA reference implementation, move it over to Mojo, run it directly on NVIDIA, and then say, hey, LLM, you can now upskill this and take advantage of a lot of the Mojo features. The code will get way shorter, but it also gets more portable. And so this ability to migrate and work with the ecosystem is made possible by things being open source. And so if you want, you can check out our model, and there's a lot of cool stuff in there. You can dive into the implementation. Again, it's all very reasonable Python code. There's nothing super surprising there. But because of the architecture work, because of these capabilities, because of this best-in-class reimagined technology stack, it actually is easy. It doesn't just look easy on a slide. Now, what about performance? I was talking about the overhead of this mishmash of weird things that are all kind of combined together. By pulling all this technology, by pulling this easier-to-use framework together, you can actually do really cool things. And so pull down our open source, you can repo this yourself. Across a wide range of different image resolutions, you get way faster results. This is how you can get to sub-second image generation. And so the reference in this case is a super widely used and widely known framework called Hugging Face diffusers. This is used for a whole bunch of different diffusion models. It's the standard. It's all tricked out. They use torch.compile. They use all these fancy features to get all the performance they can. And you can see that it's just getting crushed. And the reason for this is that Hugging Face diffusers is an amazing library. It's an amazing community. It's an amazing thing that they built. But it's all built on this legacy PyTorch and other infrastructure that can't handle this kind of workload super well. Now, what does it mean when you zoom out? Well, you can take that and you can slice the data in different ways. You look at different image sizes, and they can take different times to generate. And so compared to diffusers, it's cool that Max is something like 5 times faster. That's actually a big deal, I think, and our customers love that. By the way, if you're interested in image generation, please reach out. We're pretty good at some of these things. The other thing is that we run on NVIDIA as well. And so now you can actually do a drag race of, OK, well, whose chips works better and which is faster? Well, we put a lot of energy into NVIDIA as well. We love AMD, of course, but we put a lot of energy, and we have a lot of customers on NVIDIA. In this case, it turns out that actually the AMD chip, just on raw horsepower basis, is actually faster than NVIDIA. And so this is where, when we talk about how do we unlock the power of the silicon, it's about allowing the flops to shine through. And NVIDIA makes amazing chips, and one of the things that we at Modular love to do is allow that power to come through and allow developers to just get it and not have it cloaked underneath layers of software complexity that prevent you from getting access to it. Now, in this case, it turns out that the Blackwell and the AMD MI355, they're actually pretty comparable chips. They're built around the same time, and it's again, it's impressive that it's faster because NVIDIA is such an incredible company as well. But the thing that's really interesting about AMD, of course, is that it's actually priced much more reasonably. And so if you actually look at this on a TCO basis, suddenly the NVIDIA solution just gets crushed. It's not 5x faster, roughly. It's 6.25x better TCO. And what we hear from customers everywhere is that what they want is they want choice, yes, but they care about TCO, they care about latency, they care about all of these different things. And so we're really excited about bringing this all together into a unified solution that gives them this, because again, we love all the flops. Capacity is limited no matter whose flops they are, but the customer should have choice to pick the right thing for their design. And so we're very excited about this, and we're very impressed with our partners at AMD, of course, as well. Now, so we know this is just one example. Flux is a pretty cool model, and image diffusers are pretty interesting. Modular isn't just about Flux, obviously. I'm just picking one example of something that's pretty interesting that we did recently. We actually have a release coming out next week, which is pretty cool, and so we expand from image to video. And so it turns out that when you start talking about consuming all the flops, video is really where it is. And so we'll be launching our WAN models, which is one example of a video model that we're coming out with. It's way faster than PyTorch, as you'd expect, because, again, it was not designed for this amount of compute. Many of the frontier companies can't use standard technologies. They have to build everything from scratch. And again, this is part of the problem with if you build everything from scratch and you're on NVIDIA, you end up writing stuff just specific to one chip. And so what we'd like to do is crack this open with the community and actually lean into this. And if you're interested in video generation, please let us know, because there's a lot of great collaborations that we can do. What about text? Well, we're actually pretty great at text. Earlier this month, we were part of the Google launch of the Gamma 4 model. Gamma 4 is a really amazing frontier model. It has small versions as MOEs, and so we were very excited to launch on day 0. I gave a whole war story talk about this at an event last night. But one of the cool things about this is that this is a very complicated, very rich multimodal model. It's got text inputs, image input, video input. It's, again, small up to MOE. There's a whole bunch of different aspects of this model. It's an incredible model. American-made also, allegedly. I don't know. And so when we launched it, we put about 2 engineer weeks worth of work into building it from scratch, because Max gives you such superpowers. It turns out that at launch we were about 15% faster than VLM. But more importantly, this model was in our nightly release for NVIDIA and AMD unified, out of the box, no configuration needed, it just works. Right? And so this is the advantage of having a unified stack rather than having different vendors implementing different things and different Git repos and then trying to integrate them and upstream them and fighting with communities. And having that integrated stack makes it so it just works the way it's supposed to. I could go on and on. I will try not to do that. I do need to advance the slide, though. The clicker is not cooperating. We will come over here. Maybe not. AV team, help. Can we go to the next slide? Go for it, yeah.
Softball question. What experience do you have building compilers? Why would we?
I think the compilers are pretty cool. The cool thing about compilers is when they work and they get out of your way, so you can focus on your job. Like, most people encounter compilers when the compiler's doing something wrong and you see an IR dump or error messages telling you did it wrong. But the modular stack isn't just a compiler, right? It's actually a full set of frameworks, languages, libraries, tools. The actual currency is developers, right? And so this is where, again, building an open community, building an ecosystem that can scale is actually the alpha, right? And this is what we're really focused on. I don't know what is going on with the rest of my slides, but I can just give you a short version. So if you're interested in our stack, please check it out. Go to modular.com. We have documentation. We have tutorials. If you want to learn how to program GPUs, we have GPU puzzles. The GPU puzzles are great because they can show you how to, here you go, GPU puzzles. They can teach you how to program GPUs. One of our big beliefs, coming back to it's the humans that matter, obviously, is that a lot of folks are wanting to upskill and learn about AI and GPU programming. There's no good on-ramps for this. It's an exclusive club. Everybody wants to make it super difficult. The languages, the tools, all this complexity is really holding people down. And so we've invested quite a lot of time and we'll continue to invest into education. And so we think this is an amazing time to get involved, and everybody should be able to do this work. We have a great community. We're off to a good start. We'd love for you all to join, of course. And so we have, there's tons of downloads. We have nightly releases. We do a release every 6 weeks or so. And we're really pushing into this. And one of the other most amazing and very exciting things for me is that we'll have Mojo 1.0 coming soon. In fact, next week we'll have 1.0 beta 1. And so we're on the path to language stability. And then we're going to open source the compiler in roughly August. And so I'm very, very, very excited about this. This is a huge moment for us. The entire team's working incredibly hard. I'm an opinionated compiler and language person. I'm really happy with the way that Mojo's growing up, and I think it's a profound foundation for the future of not just GPUs and AI, but for a lot of different things. So that is the end of my talk. I want to thank AMD. It's an amazing event, and I hope you all have fun, and I'm happy to talk with you after the talk.